Hi, today we are going to see about operating system. In operating system, we are going to see about the scheduling. So what is scheduling? In a multi-programming systems, frequently multiple processes will compete for the CPU at the same times. That is, at the same time, multiple tasks will be done and the OS has to respond for that. So what we can do means we can perform scheduling for the operating system. When two or more processes are simultaneously in the ready state, a choice has to be made which process is to run next. This part of operating system is called scheduler, and the algorithm is called scheduling algorithm. So long term, and there are two types of scheduling algorithm, that is long term and short term scheduling algorithm. If we consider the batch system, there will be often more process submitted than number of processes that can be executed immediately. So incoming process or spool, that is spool to disk. The long term scheduler select process from this process pool and leaves selected process into memory for execution. The short term scheduler select the process to get the processor from among the process which are already in memory. Let us see about the criteria for scheduling. CPU utilization is the main thing, and then throughput, turnaround time, waiting time. These are response time. These are the main scheduling criteria. Let us see one by one. First one is CPU utilization. We have to keep the CPU as busy as possible. It may range from 0 to 100%. In a real system, it should range from 40 to 90% for lightly and heavily loaded system. Next one is throughput. It is a measure of work in terms of number of processes completed per unit time. For long process, this rate may be 1 process per hour. For short transaction, throughput may be 10 process per second. Next one is turnaround time. It is a sum of time period spent in waiting to get into memory, waiting in ready queue, that is execution on the CPU and doing input-output process. Turnaround time is equal to time of completion of job minus time of submission of job, that is waiting time plus service time or burst time. Next one is waiting time. The sum of period waiting in the ready queue. Response time. Response time is the amount of time it takes to start responding and the time taken to output that response. Next, let us see about the types of scheduling. Scheduling algorithm can be divided into two categories with respect to how they deal with clock interrupts. Preemptive scheduling. A preemptive scheduling algorithm picks a process and lets it run for a maximum of some fixed time. Non-preemptive scheduling. Non-preemptive scheduling algorithm picks a process to run and then just let it run until it blocks either on input-output or waiting for another process or until it's voluntarily release the CPU. Scheduling in batch systems. There are three algorithms for batch system: FCFS, shortest job first, shortest remaining time next. Let us see what is shortest job first. This is also known as shortest job first or SJF. This is the non-preemptive scheduling algorithm. Best approach to minimize waiting time. It gives short jobs a higher priority. That is, perceived response time is thus better. Easy to implement in batch systems where required CPU time is known in advance. Impossible to implement in interactive systems where CPU required time is not known. Processor should know in advance how much time process will take for that particular job. Shortest remaining time next. Shortest remaining time next is also called SRT, is the preemptive version of SJN algorithm. The processor is allocated to a job closest to the completion, but it can be preempted by newer ready job with shorter time to completion. Impossible to implement in interactive systems where required CPU time is not known. It is often used in batch environment where short jobs need to give preference. Scheduling in interactive systems, that is round robin scheduling. Round robin is the preemptive process scheduling algorithm. Each process is provided a fixed time to execute and it is called quantum. Once a process is executed for a given period of time, the process is preempted and other process executes for a given period. Context switching is used to save states of preempted process in scheduling. This is the example for round robin where we are given 4 PO, P1, P2 and P3. The time quantum is 3. The first time wait time for each process is following 0 minus 0, that is 12 minus 3 9, 3 minus 1 2, 6 minus 2 14 minus 9, 20 minus 7, that is 12, and for P3 it is 11. So the average waiting time is 8.5 minutes. Priority scheduling. Priority scheduling is a non-preemptive algorithm and one of the most common scheduling algorithm in batch system. Each process is assigned a priority. Process with higher priority is to be executed first and so on. Process with same priority are executed on first come first serve basis. Priority can be decided based on memory requirement, time requirement or any other resource requirement. This is an example for priority scheduling. Here the average waiting time is reduced to 6.5 and next one is multi-level queue scheduling algorithm. A multi-level queue scheduling algorithm partitions the ready queue into several separate queues. The processes are permanently assigned to one queue generally based on some property of the process such as memory size, process priority or process type. Each queue has its own scheduling algorithm. This is the shortest process next. Here also what happens means the first action function is done, that is process with the shortest expected path is first given and then the decision mode is given and non-preemptive and IO bound process will be picked first, then we need to estimate the required processing CPU time for each process. Next, guaranteed scheduling. Make real promise to the user about performance. If there are n users logged in while you are working, you will receive about 1 by n of CPU power. Similarly, on a single user system with n processor running, all things being equal, each one should get 1 by n of CPU cycle. To make good on this promise, the system must keep track of how much CPU each process had since its creation. So CPU time entered is equal to time since creation by n. Lottery scheduling. Lottery scheduling is a type of process scheduling somewhat different from other scheduling. Processors are scheduled in a random manner. Lottery scheduling can be preemptive or non-preemptive. In this scheduling, every process have some tickets and scheduler picks a random ticket and process having the ticket in the winner and it is executed for a time slice and then another ticket is picked by the scheduler. The process having higher number of tickets give it more chance to get chosen for execution. Thank you.